All right, today we're going to pull back the curtain on Microsoft's Semantic Kernel. Look, if you're a .NET developer and you're thinking about building those next-gen AI apps, this SDK, well, it's pretty much the key to unlocking some seriously powerful stuff.
Okay, so here's the game plan. We're going to start with the why, the big challenge that Semantic Kernel tackles. Then we'll get into the how, breaking down its architecture. From there, we'll see it in action, talk about connecting it to any LLM you want, and wrap up with how this is being used in the real world, in the enterprise.
All right, let's kick things off with a problem that I'm sure a lot of you have run into if you've been dabbling with large language models.
You know, the real magic with AI isn't just having a conversation with it, right? It's about getting that AI to actually do stuff with your systems, to talk to your databases, to call your APIs, to use your business logic. But anyone who's tried this knows that just stringing prompts together, well, it gets messy and fragile really, really fast.
So here's the core challenge, right? We have to connect two totally different worlds. On one side, you've got the LLM. It's creative, it works in shades of gray, it's all about probabilities. On the other side, you've got our code. It's strict, it's logical, it's deterministic. It does exactly what you tell it to. Bridging that gap? That's the whole reason Semantic Kernel exists.
So, how do we solve this? Let's get into the solution itself. Semantic Kernel offers this really elegant and honestly surprisingly simple architecture to tackle this exact problem.
Okay, at the very heart of it all is the kernel. The best way to think about it is like the brain of your AI app. Or, for all of us developers, it's basically a dependency injection container for AI. It's this central engine that orchestrates everything, figuring out what needs to happen and in what order.
And this is where the real magic comes in. We have plugins. And a plugin is just your code. Seriously, you take a C# method, you decorate it with an attribute, and bam, it's a tool the AI can use. Anything your app can do, call an API, run a database query, do a complex calculation, you can wrap it up and hand it to the AI as a new skill. You're literally giving the AI superpowers that are powered by your code.
And just look at how easy it is to get this thing up and running. I mean, this is it. A few lines of C#. You create a builder, you tell it which AI service you want to talk to. Here, it's Azure OpenAI. You call build, and you're done. You have a kernel ready to go. It feels clean, it feels familiar to any .NET dev.
So let's trace the basic flow, how this actually works. It all starts with the user's ask, right? They type in some goal. The kernel then acts like a smart dispatcher. It looks at the goal, figures out which of your plugins, your code, are the right tools for the job, and then invokes them. Finally, it takes the results from your code and sends them back to the LLM to craft that final, polished response.
Okay, that's great for a single step. But what about more complex tasks? You know, things that require multiple skills, multiple steps. Well, that's where things get really interesting with planners and agents. This is the true magic of orchestration.
So let's take a look at a more complex user request. Tomorrow is Valentine's Day. I need to come up with a few date ideas. My significant other likes poems, so write it in the form of a poem. See? This isn't just one thing. It's brainstorming and it's creative writing. So we can give our kernel a plugin for brainstorming and another one for writing poems. Now here's the cool part. Instead of us having to figure out the right order to call those functions, the planner does it for us. It looks at the user's goal, it understands what all of our plugins can do, and it creates a multi-step plan completely on the fly. It figures out, okay, I need to use the writer plugin for this, and builds the whole sequence of actions automatically. It's like it's writing the orchestration code for you in real time.
And boom, there's the result. A poem generated completely automatically. This just shows the power, right? Semantic Kernel can take that high-level, vague goal and turn it into a concrete set of actions, chaining your functions together without you having to write a single line of that complex if-this-then-that logic.
Now, one of my absolute favorite features of Semantic Kernel is that it's model agnostic. And this is a huge deal. It means you are not locked into one AI provider. You have total freedom, total flexibility.
So, you get a choice. You can tap into the massive, powerful cloud models from places like OpenAI and Azure, or you can run models right on your own machine. Using tools like Llama or LM Studio, you get complete control and, crucially, complete data privacy.
And check out the code to see how simple this is. To switch from a huge cloud provider to a model running on your laptop, you literally just change the model name and the URL to point to localhost. That's it. Think about how fast that makes development and testing. It's an incredible level of flexibility.
Okay, this is all great tech, but how does it actually play out in a business environment? Let's dive into some really powerful enterprise patterns that this whole architecture just lights up. Okay, first up, natural language to API. This pattern is a total game changer. Think about it. You take your existing APIs and you just expose them as plugins. Suddenly, your users can interact with your entire system just using plain language. And check this out, it works in any language. A user types a request in Portuguese to create an invoice. The LLM gets the intent and calls the right API. Just like that, you have out-of-the-box multilingual support. That saves an unbelievable amount of development time.
Next up, a pattern called agentic RAG. Now, you've probably heard of RAG, Retrieval Augmented Generation. That's where you find some documents and feed them to the AI. Agentic RAG is the super smart version of that. The agent doesn't just grab data, it reasons about the query. So instead of just finding a document, it might break down the user's question into smaller pieces, run multiple searches, and then reflect on all the information it found before putting together the final answer. The result? Way more accurate and context-aware responses.
And of course, in the enterprise, performance is everything. The great thing is, because Semantic Kernel is built on top of .NET 8, you get all these amazing platform optimizations for free. For example, Dynamic PGO is on by default, and that gives you an average performance boost of around 15% for AI workloads. So what does that actually mean for you? It means your app responds faster and your cloud bill goes down, all without you touching a single line of your code.
All right, and for any real-world production application, observability is just non-negotiable. You have to know what's going on. Semantic Kernel was built with this in mind. It emits standard open telemetry data right out of the box. You can track how long your functions take, how many tokens you're using for prompts, how many for completions, everything you need. This lets you monitor your AI's behavior, its performance, and maybe most importantly, its cost once it's live.
So let's end with this thought. The biggest shift here is that Semantic Kernel flips the script. It's not about you calling an AI service anymore. It's about the AI calling you. It asks you to think about all your application's capabilities, all that business logic, not as code, but as a set of skills, a set of superpowers that you can give to an intelligent agent. And that really is the incredible future it helps us build.
If this helped you tighten up your app, hit that like button, share this video with another developer, and subscribe to The Curious Dev for more deep dive tutorials like this.